Let's do some more examples on obtaining the power series representations of given functions. So let's take this one. Now in all these cases, what we should try to do is to convert the given function in this format, that is the format of 1 divided by 1 minus something, right? So because then we will have this relationship sigma of this something to the power n starting from 0, where this something is the modulus of this term is less than 1. So this is kind of the general equation that you should have in mind. So whatever the term we use here, you will replace all these places, right? So when you have this sort of a function, in order to find the power series, we should first try to convert the given function in this format, because after that everything will flow smoothly, right? So if we try to do if you try to adapt that technique for this function, we can rewrite it like this. Now see here, as the starting digit of the denominator, you must have 1, okay, not any other number. So to do that, we need to factor out 2 from the denominator. So you will get 1 here and x divided by 2 here. So we will have half times 1 over 1 plus x divided by 2. And now we are done with this digit 1. But then we need to have 1 minus, but here you will have 1 plus. So then we have to rearrange that as well, right? So that can be done by this one. Here we have 1 and 1 minus. Now remember, you cannot change the original terms, okay? You cannot just write it as 1 minus x over 2, right? You have to be careful that you are not changing the original problems, okay? When you are doing these rearrangements, you have to be very careful that you are not changing the original problem, right? See, now here, although I have converted it to this format, I have not changed anything, right? It's like if we just simplify all these brackets, you will end up with the same original problem. But if we just write it as 1 minus x over 2, then this one and the original problem are two different cases. So you have to be careful with these rearrangements, right? And then you can see that this is exactly the same format as it is written in here, right? So here for this term we have negative x over 2, right? So what we can do is we can rewrite it in the power series representation. Now half stays the same and it is multiplied with the sigma n equals 0, and for this term you will need to write whatever the term you have here, that means in here after this negative sign. So there you will have negative x over 2 to the power n, and for this region also you must write whatever the term you have here. So in this case what you have is x divided by 2, okay? Now this is important, right? So in other words, it says 1 over 2 plus x is equal to half sigma negative 1 to the power n x to the power n over 2 to the power n starting from 0 when x is less than 2, right? See here, now the region is different, right? So this says for all the x values, within this region with the modulus less than 2, starting from 0, -2 and 2 with open brackets, right? So for all these x values, we can write this function as a power series. Now you can even simplify this series representation a little further, right? You can take this 2 inside the series and write it as 0, infinity, -1 to the power n divided by 2 to the power n plus 1, because of this outside 2. When you take it inside, what you have is 2 to the power n times 2, and that is equal to 2 to the power n plus 1 and times xn. See, now you can see that this is a power series representation, right? The center is 0 and the Cn sequence is this one. Okay, so we have represented the function, the given function, as a power series, but this equation is true only for this region, right? Now remember, in the very first initial equation the region was different, but from this region we were able to compute the new feasible region for this particular function. So you have to be familiar with these techniques, right? First you should convert the given function according to this pattern, and then directly write the series representation, and then you should obtain the suitable region by directly using whatever the term you use here as 1 minus this term, right? Okay, and in the next video also we will practice some more examples.